Hi everyone. In this video, we try to understand what is a predictive model in machine learning. So you can consider predictive model as something that exists inside the computer. And when we put all the factors, like there is something inside the computer, when we put all the factors which might affect the eventual outcome, it comes up with some prediction. Okay, that this is for prediction. And these are those factors which we had input under this model. Right? Mathematically speaking, it is some function. For example, we might want to know what will be the sales for the day to day, and we consider some factors for that shop. Example: temperature, rainfall. Okay, uh, the sale last year on the same day. Okay, last year, same day. Okay, so these may be the different factors. All right, we call them collectively as xi. Okay, where x is collectively all the factors, xi is an individual factor. Like this is x1, the temperature, x2 factor rain, X3 factor the sales on the same day last year, collectively called as X. Consider all these factors gone into some predictive model, and based on the combination of these factors, the working among themselves, the model predict the sales for the shop for the day today. Is that clear? Fine. Okay. Now, prediction made by this function, let us consider this model, this something to be a function. As I told you, mathematically, you can call this box as a function, right? Function of all the factors, right? Prediction made by this function is called as y. I hope you got it, right? Yi or y hat. Right? Now, when you consider only yi, this is the real outcome. And when you talk about why I had, this is the predicted outcome which came out as a result of function. All right, fine. Now, when we consider about the real outcome yi, this is always expressed as predicted outcome with some errors. Okay, this epsilon is nothing but for an error observed for that particular observation. What does this mean? For example, I want to predict what score will Team India score today based on some performance factors, maybe the boys who are playing the match, maybe the weather of the day, maybe the innings, or maybe many other factors that you can consider, right? Suppose my prediction was the team will score 292, but the team actually scored 275. Now you can see here in this case, what you predicted was greater and what was the actual outcome that was lesser. The difference between the two, roughly, in this case, error being negative, okay, that is minus 30, right? This could have been the opposite case also. For example, I guessed, I guess the team scores 275. Hmm? I guess the team scored 275, but the team has actually scored 295. All right. So this time the difference between the two is positive, right? So real outcome is always the predicted outcome plus some error associated with. This error can be negative. This error can be positive. Exactly. Fine. So what do we expect from our model or a predictive model? It should be accurate. Okay, as accurate as possible, but accuracy is not limited to one single observation. When I say observation, this means a record. Okay, OBS is for observation. This accuracy must not suit a single observation. This should be collectively applicable to all the observations. Like for example, there are 10 observations or 1000 observations in the database. What your model predicted the target as, it must be accurate for every single observation. Now, how do we go about this? Like you want it as accurate as possible, but collectively accurate, like not just one time. So how do we go about it? Means we want some concrete form of solution for that. Is that okay? Like for example, my model predicted the score Team India will make one day very correct, or maybe closely up or down by 1 or 2 runs. And the second, third time it predicted somewhere two of the values. The team has scored 150, but my model predicted 275. Or the team has scored 275 and the model predicted 80 or 90. Right? So that must not happen. One day very close to it. Other 2 days too far. All right, so the solution to this problem is we need a concrete solution that in ML is called as algorithm. Is that okay? This is something we call it to be algorithm. Now today let me talk about a very basic form of this function which I was talking about. That is a linear regression. Okay, so consider f of xi, this function to be a linear combination of some underlying conditions or factors. Right? For example, I express my function as linear combinations of these constants beta, this is beta 0, beta 1 with the factor x1, beta 2 with the factor x2. Is that okay? Where x1, x2 are the underlying conditions, factors, inputs. I hope you got my point. They're also called as predictor variable. These are input. For example, this may be, let me call it to be temperature, and x2, let me call it as rain. Okay. Now, accuracy of this function depends on how correct the values of these constants you select. Is that okay? For example, let me consider beta 0 to be 100, beta 1 to be 10, and let me say beta 2 to be minus 5. Is that okay? And now when the temperature is, for example, 20 degrees, so this I multiply with 20, and rainfall, assuming it is 50 mm, so I multiply by 50, and I tend to get some answer. Is that okay? So basically, this beta 0, beta 1, beta 2 are some fancy names of coefficients the linear model or this mathematical functions use. I hope you get my point. This expression or equation is for one single observation. This entire equation is for one single observation. This way you can substitute the different temperatures and rainfalls from different observations, substitute in this equation with the same values of beta 0, beta 1 and beta 2 and get the prediction out. Is that okay? Right now, error in this model will be expressed as, suppose EI, this is error for that particular observation, which will be equal to YI, that is the real outcome, minus beta 0 plus beta 1 into x1, beta 2 into x2, up until beta n into x, because this equation is what is going to give you a predicted outcome. Is that it? Fine. Now, collective error, what do you call it to be? Before that, try to understand we want to have a prediction framework in a way that it must have as low as possible the collective error, because the expression that I just tried before was for a single observation, right? But the predictive model framework does not talk about a single observation, error in a single observation. We're talking about collective error. So collective error, okay, collective error, okay. This is sum of all the errors. Okay, say error for observation 1, error for observation number 2, error calculated for observation number 3, and this way, error calculated for observation number n. So if you say E1 plus E2 plus E3 up until all these observations, say error for observation number n, that is going to be the collective error. Now we want this collective error to be as small as possible. Okay, instead of writing the expression this way, you can simply call collective error to be summation of all the errors starting from 1 to n. Is that all right? Now the thing is what, in case if you calculate collective error this way, there are always chances that some positives and negative may cancel out each other, and the result of the collective error is zero, which is not possible because no algorithm in the world is ideally too fit to give you zero error. Hmm? And if that happens, you have to be a bit suspicious. That means it is too good to be true. But that cannot happen. For example, error in observation 1 was 10, but error in observation number 2 is minus 10. Now this 2 is going to cancel out each other, thereby leaving you with collective error as 0. But that is practically not true. Is that okay? Fine. So we have to come out with some way which is not just the calculation or addition of these errors as a collective error. The most popular ones which are used to calculate the collective errors are called as sum of the squares of the error. That means collective error, we simply square each of the individual error and take its sum. Okay, fine. Because when you square a number, if it's a negative number, it's going to give you result as positive, and even if it's a positive number, of course, it's going to be positive. So this is one way to remove the effect of sign, right? This is nothing but mean square of all the errors. Other one popular function or method to calculate collective error is to take an absolute values, the sum of absolute values. For example, for all the observations from 1 to n, n could be 1000, million, 10, or just 100, maybe, right? Instead of adding individual error, we add the absolute values of these errors, calling this method to be mean absolute errors. Remember one thing, to minimize the error, whether in this case or in this case, we want to select the values of beta in a way that error is minimized. All right. If you have remembered, the betas are those constants that we use in the function to predict an outcome. Correct? Like beta 0 plus beta 1 into x1, beta 2 into x2 up until beta n into xn. Alright, so these betas, which are these coefficients or constant, this must be selected in a way that errors are produced as normal as possible. Alright. For example, while calculating sales, when I take beta 0 as 100, beta 1 as 10 into x1, and beta 2 as minus 5 for x2. All right. So I would expect whatever x1 and x2 are, whatever is the temperature and whatever is the rainfall, okay, these values when kept constant is going to predict the sales with least error or minimum error, right? So getting some beta values for which this cost function will be lowest. Okay, this is called as a cost function, the one which will help you to calculate the error, minimum error. All right. Now the thing is, the problem is, for example, while calculating the error this way, assuming that I got sales as 2000, of course, this is not 2000. The calculation is going to give you some different outcome as well. I assume, say, the sales came out to be 2000. So next time I decide, let me use beta 0 as 75, beta 1 as 20 instead of 10, and multiply by x1, maybe temperature or whatever. Okay, and beta 2 as simply 10 multiplying with the okay, multiplying with the factor x1 or x2, my bad, it should be x2. Is that okay? Multiplying with x2, right? Now, this time when I calculate the answer, maybe I get the predicted sales as 1500. I hope you got my point. So I switch my beta 1, beta 2, beta zeros from these three constants to now this constant, maybe 75, 20, and 10, correct? These are the values 75, 20, and 10. Right? So this can go on really for very long, like as long as we have time, enough time and resources to do that just to get some better beta values so that errors or the cost function can be lowest. Now, this should not be practically acceptable, okay, because we will not keep trying this with any random number, meaning we need more strategic way of changing betas and at the same time getting closer to more and more smaller values of the cost function rather than selecting some random values. This more strategic way of moving towards optimum values of my parameter is called as gradient descent. Gradient descent. This is called as gradient. I repeat one more time. This more strategic way of moving towards optimum values of my parameters is called as gradient